2023, Chapter 1. Electrostatics. 1.12 GAUSS LAWOR GAUSS THEOREM. Gauss's law is the very powerful tool of electrostatics. It can be used to find total flux associated with the closed surface due to charges appearing in the space. By doing this, we can calculate electric field at any point of the surface. According to it, the total flux of the net electric field through a closed surface Gaussian surface equals the net charge enclosed by the surface divided by EP. Thus, if N is the total charge inside the closed surface, then Dan. Proof of Gauss's law. Consider charges 992, 9 are inside a closed surface and charges Q192, Dn are outside the surface. If B, as E9L, E2 are the fields produced by the respective charges inside and outside the closed surface, then resultant electric field at any point P on it. The flux of the resultant electric field through the closed surface. FE day. 9 N9. Dag. 92. Fig. 1.76. Here, EA is the flux due to charge G, which is GEP, and EPED is the flux to charge 9, which is 0 because it is out off the closed surface. Thus, equation 1 can be written as 992 9 N E0 SE10 0 U1 e.g. N ETA Sin 2. Note 1. The net charge is the algebraic sum of all the enclosed positive and negative charges, and it can be positive, negative, or 0. 2. The electric field appearing in the Gauss's law is the net electric field due to all the charges present inside, as well as outside the closed surface. On the other hand, the charge appearing in the law is only the charge inside the closed surface. The following observations are useful in calculating total flux. 1. 2. If E is perpendicular to a surface area as 0, 0 at all points and has the same magnitude at all points of the surface, then Ayesha coached AEADAA. For spherical surface E4 x 472 4 ter 2. If E is parallel to a surface at all points ELX 0 or 0 delta 90 deg and therefore beta t cos 90 deg 0. 3. If E is 0 at all points of a surface, the integral is 0. The surface to which Gauss's law is applied need not be a real physical surface, such as the surface of a solid body. Indeed, in most applications of this law, one considers an imaginary or geometrical surface that may be an empty space, embedded in a solid body, or partly in space and partly within a body. 5. 2023 Bilal Noor. Conductor with excess charge. If an excess charge is placed on an isolated conductor, the charge will move entire over the surface of the conductor. It is because of the fact that like charges repel each other, our internal electric field does appear as the conductor is being charged. However, the excess charge quickly distributes itself such a way that the internal electric field is 0. The movement of charge then ceases, and the net force on each charge is 0. The fact can be verified by Gauss's law. It has explained that the electric field E is 0 at all points within a conductor, when the charges in the conductor are at rest. We may take our imaginary surface in the interior of the conductor as shown in figure, because E is 0 everywhere on the surface. Phi. By Gauss's law. Theta. Yin. Cavity. Fig. 1.78. Fig. 1.79. Which gives cavity in the conductor. Suppose there is a cavity in the charged conductor, and there are no charges within them. Gaussian cavity. Surface for the surface A. FEL. Since E is 0 in the conductor, cavities T0. Furthermore, consideration of a surface such as B shows that the net charge on the surface of the cavity must be 0. Thus, the entire charge on the conductor lies on its outer surface, not on the cavity wall. Charge placed inside the cavity. Suppose that there is a conductor inside the cavity but insulated from it, and that the Gaussian surface inner conductor has charge G by Gauss's law. Dead. Fig. 1.80. Car. Since E is 0 inside the conductor, which gives in S0 as the charge inside the cavity is G, so there must be a charge on the cavity wall, equal and opposite in sig to the charge G, if outer conductor is initially uncharged before the charge, AI, is inserted. There must be a charge on its outer surface, equal and opposite to the charge on the cavity wall, that is G. Consider a charged conductor having charge Q initially. A charge Q is placed in cavity in the conductor. The charge on the outer surface of the conductor QG. 2023 Bilal Noor, lines of field inside cavity due to charge at its center. Hazel spherical cavity. Xe egg VA. A E egg VB. Fig. 1.81. Conductor in external electric field. Consider an uncharged conductor is placed in an external electric field. The free electrons in the conductor distribute themselves on the surface as shown, reducing the net electric field inside the conductor to 0 and making the net yield at the surface perpendicular to the surface. Potential OI earthia conductor is 0. Let us consider two concentric conducting shells. Inner shell is given a charge Q. The charges are induced at outer shell. As shown in Fig. 1.83, the potential of any point on the surface of outer shell, 47 ED. ATN. Now let outer shell is earthed. The charge on outer surface of outer shell neutralized by electrons coming from Earth. But negative charge on inner surface of outer shell remain intact because of attraction of charge of inner shell. Potential at any point on outer shell, 4 TeA. Fig. 1.82. Fig. 1.83. X. 28. A point charge G is placed on the apex of a cone of semi. Fig. 1.84. To find